Trigonometric ratios in a right-angled triangle. The concept of similar triangles that we saw earlier is fundamental to defining the trigonometric ratios. We know that the corresponding angles of the two similar right-angled triangles ABC and DEF will be equal. Let us consider angle A to be theta. Therefore, angle D will also be theta. The third angle will be 90 degrees minus theta, because the sum of the angles in a triangle adds up to 180 degrees. Recall that the side opposite to the right angle is the hypotenuse. So, hypotenuse AC corresponds to hypotenuse DF. Now, consider side EF. This side can be seen as a side that is opposite to this angle theta. So, if you go across the angle D, you will see side EF. Similarly, side BC is opposite angle A. So side EF corresponds to side BC. Finally, side DE corresponds to side AB. What can we say about sides DE and side AB with respect to the angle theta? Well, we can see that side DE is one of the arms of angle FDE. The other arm is the hypotenuse. Since side DE is adjacent to angle theta, we label this side as adjacent side. Similarly, side AB is the adjacent side with respect to the angle theta. We have now labeled all the three sides of the triangle with respect to the angle theta. Let us now calculate the ratio between the corresponding sides. Recall that in similar triangles, the ratio between the corresponding sides is going to be the same. Let us consider the opposite sides first. The ratio of the lengths of sides BC and AC is going to be equal to the ratio of the lengths of the sides EF and DF. Therefore, BC over AC equals EF over DF. This ratio opposite side over the hypotenuse is called the sine of theta. Similarly, we can also say that the ratio of the lengths of sides AB and AC is going to be equal to the ratio of the lengths of the sides DE and DF. Therefore, AB over AC equals DE over DF. The ratio adjacent side over the hypotenuse is called the cosine of theta, cos theta in short. Finally, we can say that the ratio of the lengths of sides BC and AB is going to be equal to the ratio of the lengths of the sides EF and DE. Therefore, BC over AB equals EF over DE. This ratio opposite side over adjacent side is called the tangent of theta, tan theta in short. We need to remember that the trigonometric ratios are independent of the lengths of the sides of a similar triangle and depend on the angle theta. We can denote any of the two non-right angles as theta. Once theta has been defined, we label the remaining two sides of the triangle based on their position with respect to theta. These trigonometric ratios remain constant for the specific angle theta because the definition is based on two similar triangles having proportionate sides. An easier way to remember these ratios is to memorize the word SOHCAHTOA. Sine theta equals opposite side over hypotenuse. Cos theta equals adjacent side over hypotenuse. Tan theta equals opposite side over adjacent side. S stands for sine, O stands for opposite, and H stands for hypotenuse. C stands for cos, A stands for adjacent, and H stands for hypotenuse. T stands for tan, O stands for opposite, and A stands for adjacent.
Need more help? Subscribe to our channel. Can't wait that long? Ask Masky to help you and let the math finally start mathing.